Assalamualaikum and hello everyone. We are from Group 4 and today my group will teach you a subtopic about the stress-shortening cycle relationship. Okay, before we start the presentation, my name is Muhammad Hairi and my group members is Alif Iskandar, Syafiq Kidran, Alia Fatiha and Nadia Natasha. Okay, first now, we will go to the first slide, which is what is the stress-shortening cycle? What are the definitions of stress-shortening cycle? Okay, so the stress-shortening cycle, also known as SSC, it is a phenomenon which characterized by the enhancements of power production in our concentric muscle action preceded by active muscle while stretching, also known as eccentric muscle action in comparison with the same concentric action preceded by a resting state. Okay, the stress-shortening cycle can improve our muscle power production by 50% in some tasks such as jumping, running or any activity that requires explosive power production. Okay, now we will go to the second slide. Okay, in this next slide, I will explain about what is the purpose of stress-shortening cycle. The stress-shortening cycle occurs and used by any athlete that involved in fast movement sports such as sprinting, running or jumping in a football match to header a ball. It involves a pre-stretch muscle and then a counter movement where the muscle is actually contracting to produce enough force and momentum to complete the task. Okay, next, the third slide is about the rate of loading for stress-shortening cycle relationship throughout the sport that we participate. Okay, by any research, the action of the stress-shortening cycle is best described as a spring-like mechanism that can be compressed and released with a full extension of power. It also works by increasing the speed at which the coil is compressed or how hard it is pressed down, which we can refer such as amount of force applied onto the spring. Therefore, a jump which includes a run up sometimes will often allow an athlete to jump higher or farther than a jump from a static position, because of an increase in the rate of the loading. That's all from me. Next slide will be presented by Alia Fatiha. Thank you for listening.
Okay, next I will talk about phase of muscle contraction that involve three phases, that is eccentric phase, amortization phase and concentric phase. For the phase 1, eccentric phase is eccentric contraction that occurs when the total length of muscle increase, extension is produced. For example, the lowering phase of a bicep curl constitutes an eccentric contraction. Muscles are capable of generating greater force under eccentric condition than under either isometric or concentric contraction. For example, as we are going down, for example for vertical jump, the muscles are lengthening during this phase, especially our quadriceps and gluteus. So in this situation, we are going into the eccentric muscle contraction, which is we are controlling the motion of lengthening. Next, I will continue about second phase, that is amortization phase. The amortization phase is the time delay between overcoming the negative work of the eccentric pre-stretch to generating the force production and accelerating the muscle contraction and the elastic recoil in the direction of the plyometric movement pattern. The phase of the stress-shortening cycle, that is SSC, is perhaps the most critical in production of power, as the duration of amortization must be kept at a minimum. This phase is really important for our strength, power and speed. This phase is where the stress-shortening cycle SSC starts to give us our elastic recoil. For example, during the amortization phase, there is stored energy. So when we stretch the tendon, that stored energy will be depending on the strength, on the length of the amortization phase. Recall back during the contraction phase to give power. Okay, for the last phase, that is concentric phase. In a concentric contraction phase, the muscle tension rises to meet the resistance, then remains stable as the muscle shortens. A concentric contraction is a type of muscle activation that causes tension on your muscle as it shortens. As your muscle shortens, it generates enough force to meet an object. This is the most popular type of muscle contraction. For example, on the way up during jumping, we are going into a concentric muscle action, which is we are shortening the muscle and jump as high as we can, like a spring concept.
Okay, for my part, how does this apply to training? For example, now involving the stretch-shortening circle. First, when we are going through a vertical jump training, we have a couple options where we can do static vertical jump, where we just squat down and hold a squat for 3 seconds and the jump straight up. Second, it just corresponds to just the active muscle contribution to jumping, and it's not involving the stretch-shortening circle relationship at all. Okay, next, how to effectively train the stretch-shortening circle. The faster the counter movement, the more contribution we get from the muscle and the mechanical aspect of the stretch-shortening circle itself. For example, with a deep jump, basically stepping off a box and falling in a certain short distance, and the landing at the ground with short ground contact time and immediately jumping back. Okay, let's think about the muscle action involved on the next slide. Okay, muscle action involved during training with a deep jump. Starting from going down to hit the ground, we will going to hit the ground and then quickly have to transfer our momentum from going down to jumping up. This situation going to be a big change in momentum, and it will involve a large eccentric stretch on the muscle and then a quick rapid concentration to jump up after that.
Next, I will continue the present. I will talk about effect of stretch-shortening relationship training. If this stretch-shortening cycle training program effectively, this can be a really effective way to help those athletes achieve their explosive power, such as Cristiano Ronaldo. Cristiano Ronaldo can jump almost 2.56 meters above the ground when scoring a goal. It also will help the athlete to produce more force and move quicker while doing some sport activities. Next, we go to the mechanism of stretch-shortening cycle. There are numerous neurophysiological mechanisms thought to contribute to the SSC. Some of which include storage of elastic energy, involuntary nervous processes, active state, length tension characteristic, pre-activity tension, and HH motor coordination. Despite this last list, it is commonly agreed that there are three primary mechanisms responsible for the performance enhancing effect of the SSC. There are three mechanisms. It is storage of elastic energy, neurophysiological model, and active state.
Okay, next we go to the storage of elastic energy. The concept of elastic energy is similar to that of a stretched rubber band. When the band is stretched, there is a build-up of stored energy, which when released causes the band to rapidly contract back to the original shape. In human, the stretch of elastic is instead placed upon the muscle and tendons during movement. This means that the muscle must contract and stiffen prior to the beginning of the exercise during ground contact, known as muscular pre-activity. The muscle must then remain contracted during the first two processes of the exercise in order to transmit the isometric forces in the tendon. This causes the deformation of tendon and the development of the storage elastic energy. That's all from me. I will pass to the next presenter.
Bismillahirrahmanirrahim. Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Idran bin Yusdi. Will present to you and explain two of the three mechanisms of stretch-shortening cycle, which are neurophysiological model and active state. First, we go to the neurophysiological model. What is neurophysiological model? Neurophysiological is a study about nerve cell, also known as neuron, that they receive and transmit information. Dalam erti kata lain, neurophysiological merupakan kajian tentang sistem saraf yang dalam aspek fisiologi di bahagian-bahagian yang tertentu. So, the neurophysiological model for stretch-shortening cycle is located in the muscle and tendon, which contain sensory receptor, which known as proprioceptor. What is proprioceptor? This receptor function is to send information to the brain about changes in length, tension, and joint angle. The proprioceptor is located within the muscle, also known as muscle spindle, with those in the tendon are called Golgi tendon organ. So this is the image that we provide to show you where is the location of Golgi tendon organ, because in the Golgi tendon organ is contained by proprioceptor. So we can see that the location of Golgi tendon organ is really in the tendon itself. So we go to the next slide, which explain about the third mechanism of stretch-shortening cycle, which is active state. What is active state? The active state is the period of time in which force can be developed during the eccentric and amortization phases of the SSC before any concentric contraction occurs. Bagi mana yang tidak tahu, SSC merupakan short term kepada stretch-shortening cycle. For example, during the counter movement or dropping action of the CMJ, the active state is developed during the eccentric and amortization phase. That unpinning belief in that exercises, which possess longer eccentric and amortization phases of the SSC, will allow more time for the formation of cross bridges, therefore enhancing joint movement and thus improving concentric force output. Increasing the amount of force and the time available for force for the force and the time to develop typically leads to a current increase in impulse. For additional information, impulse equals to force multiplied by time. In other words, increasing the force application will lead to improvement in power output and therefore athletic performance. So, with that slide about active state, it is the end for our presentation that recap about the stretch-shortening cycle relationship. Before we end our presentation, kindly we invite you to watch our short video that we provide that explain to you more detail and more visual about stretch-shortening cycle. Please enjoy. With that, thank you.
So in this video today, we're going to be talking about the stretch-shortening cycle. Now, the stretch-shortening cycle relates to the stretching of the muscle and then the reflex activity that occurs that causes a contraction. Now, in its basic form, this is called the myotatic reflex. The myotatic reflex, if we take a look at my knee and my quadriceps, can be illustrated as such. If we had a hammer, but I'll use my hand in this case, and it hits the patellar tendon, like so, we have the typical reflex reaction. Why does that happen? Well, when I hit that tendon, the tendon is indented and it stretches my quadricep muscle. Inside my quadricep muscles, of course, are what are called extrafusal fibers, which is the muscle itself, but there's also intrafusal fibers. These intrafusal fibers are known as muscle spindles, and the responsibility of muscle spindles are to detect the extent of changes in range of motion and the rate at which muscle changes in range of motion. Now, the muscle wants to protect itself, and if it senses that the muscle is going to be stretched too far, then what it wants to do is to contract in order to protect. So once again, what will happen is that I will stretch the quadriceps, a signal goes back to my spinal cord, to the motor neuron, monosynaptically, so one synapse, and activates a group of motor neurons of the quadriceps. Sends that signal down, depolarizes those quadriceps, and then I get the kicking action. So once again, we have hitting the tendon, stretch the quadriceps, spindles detect, send signal back to the spinal cord, contraction of the quadriceps, leg kicks. Now that's a very simple reflex, but we can use that reflex to our advantage when we're jumping. In addition to the reflex action that we just talked about, there's another component to the stretch-shortening cycle as well, and that's the mechanical component. So we just mentioned about how the tendon works to activate the muscle spindles to have that myotatic reflex. But the connective tissue within the muscle and the tendon acting as connective tissue acts like an elastic band. So you can imagine if we had something elastic, such as we have here, that when we stretch that elastic, it snaps back. So when we're using the stretch-shortening cycle, what we want to do is we want to take advantage of those two effects, the reflex effect and the effect of your connective tissue acting like an elastic band. So for example, if I'm going to do a jump, I could do a jump in a number of different ways. One way to do it would be just to go down and rest at a certain position. Now that I'm rested at a certain position, the muscle length has changed, but I'm keeping that position. So the reflex, which only takes perhaps less than 100 milliseconds, around 100 milliseconds, or 1/10 of a second, has turned off. And I've stretched my connective tissue, but it's starting to creep back. And so if I jump now, we'll see how high I can jump. All right. So we can see that height, a 14-inch jump. We'll just put the back in its original position. So that's called a squat jump. A squat jump does not take advantage of the stretch-shortening cycle. Now, if I want to try and take advantage of the reflex and the connective tissue, I'll want to try and stretch my muscles at a faster rate. The faster I can stretch them, the greater I'll activate that stretch shortening reflex and get a greater activation of my quadriceps. Also, it'll make my muscles, connective tissue, and tendons act like a bigger rubber band that'll snap back. So what I'll do now is what's called a counter movement jump. In a counter movement jump, I'll go down fairly quickly and go right back up very quickly in order to take advantage. So now we'll start. So this time, I've gone 19 inches. So I increased my jump by 5 inches by taking advantage of the stretch shortening cycle. When I moved down quickly, I stretched my quadriceps, I stretched the spindles, I got a reflex reaction. When I went down quickly, I stretched my connective tissue, I got a rubber band. I snapped back up and took advantage of that rubber band and the reflex action. So when people are doing activities such as plyometrics, which involves a lot of bounding and hopping, this takes advantage of the stretch shortening cycle. Sometimes with plyometrics or other activities, you can be at too great a height and inhibit the stretch shortening cycle. So what's going to happen now, I'm going to jump off this table and see if I can get as high a height as I did with the counter movement jump. So here we go. All right, this time I could only jump 12 inches. So you would ask yourself, he stretched his muscle, he should get a stretch shortening cycle, he should be able to jump higher. What happened? Well, the problem was the transition time or the contact time. Remember I said that the reflex takes 100 milliseconds or less. When I jump from too high a height, I have to absorb the shock of landing. So to absorb the shock of landing, I was on the ground for probably 300 milliseconds or 400 milliseconds so I wouldn't hurt my knees or my back. So the reflex had already gone. And then the rubber band action of my connective tissue already snapped back by the time I took off. So similar to the squat jump, where I went down and I held that position, I lost the reflex, I lost the rubber band effect, and then I jumped up. And my squat jump wasn't as high as my counter movement jump. So in order to effectively use your stretch shortening cycle, for each individual, there is an optimal height that you can jump where you can utilize that reflex without being on the ground too long. Another aspect is that when I jump from a great height, there are organs in my tendons called Golgi tendon organs. These Golgi tendon organs detect tension, and they're inhibitory. So if I'm jumping from a high height and there's lots of tension, being my body weight from a high height, hitting the ground, they send an inhibitory signal back to my spinal cord, to my motor neurons, to turn them off, to inhibit them. So not only did I get my stretch reflex was delayed, my connective tissue had already bounced back, but then the Golgi tendon organs tend to turn off the motor neurons, and thus I don't jump as high. So in summary, stretch shortening cycle, you want to get the optimal height for the muscle spindles to react to get the reflex, and you want those connective tissue to snap back in time so you can take advantage of both those effects to get the greatest jump possible.